Hello students, how are you all? So I'm back with another video. It's a continuation of electricity part 1. Now in this lecture, so we are going to solve numericals based on combination of resistors, that is series and parallel combination. At the same time some other topics also will get included. So I'll give you a note before the topic I'm going to solve. Just get ready with it. So before you solving numericals, before you see this video, it is better to revise the notes that you have so that it is very comfortable for you to understand all the things that I'm explaining. Okay, let's get started. Okay, so let's solve question number 37. Let me read it out. In the circuit shown below, the readings of the voltmeter and ammeters will be. Look at this. This is the diagram they have given and they are asking what are the readings of voltmeter and ammeter. Okay. Let's solve this question. Before solving this question, I would like to give one note point. So the note point is about voltmeter and ammeter. Ideal ammeter and ideal voltmeter. Ideal voltmeter. Meaning of ideal voltmeter, its internal resistance R internal is equal to infinity. For ideal ammeter, internal resistance is 0. Ideal ammeter, internal resistance is 0. This is for ideal cases. For practical cases, it is not equal to infinity, not equal to 0. Okay. So based on that point, let's solve this question. So if it is internal resistance is infinity, we can replace it with open circuit, right? We can replace it with open circuit. If internal resistance is 0, we can replace it with short circuit. Okay, just observe this. So how can we replace the given circuit? So here in circuit 1, this voltmeter V1, I can replace it with a open circuit. Voltage across 10 ohm resistance is nothing but V1. Okay. Similarly, this ammeter you just can replace with a short circuit. This is how it is. So whatever the current flowing through this ammeter, that is equal to I1. Okay, so that's the meaning here. So let's observe the question number, next diagram. So as voltmeter internal resistance is infinity, you can remove this 10 ohm resistance. That means current flowing through this is 0. So the voltmeter reading is nothing but voltage across this internal resistance V2. If you remove 10 ohm resistor which is in series with the voltmeter, current flowing through that is 0 just because internal resistance is infinity, right? Nothing but voltmeter reading gives you voltage across the 10 ohm resistor. Similarly, if you replace this ammeter with a short circuit, current flowing through ammeter is equal to I2. So these are the things I have to find. If you observe the circuit, so first circuit and the second circuit looks like a similar, same resistance, same supply voltage, then which option may matches? Option D is the correct answer. Hope you understand. You can calculate the value of voltage. The total voltage is nothing but 10 volt. The 10 volt will appear across 10 ohm resistance. So 10 by 10 1 ampere. So current in the first circuit and the second circuit is same. Second voltage across resistor in the first circuit and second circuit is also same because circuit is similar. This is how we have to replace the given circuit. Hope you understand. So let's move on to the next question. Let's solve the next question. 6 similar bulbs are connected as shown in the figure with a DC source of EMF E and 0 internal resistance. The ratio of power consumption by the bulbs when they're given two different cases. In case 1, all are glowing in section A. In the section, in second case, in this situation, when 2 from section A and 1 from section B are glowing. Okay. Observe the first case. In the first case, they said all are glowing. All are glowing. As all the resistors are glowing, can we replace a bulb with a resistor? Yes, it is. So let me replace a bulb with a resistor. They said all are glowing. So if all are glowing, then we can replace the circuit like this. Okay, just observe this. Observe the diagram. In case 1, they said all are glowing. All are glowing in a sense, all the bulbs can be replaced with the resistor, and they said they are similar bulbs. That means you can replace it with the similar resistance. But in situation 2, so the thing they are saying is 2 from section A and 1 from section B are glowing. 2 from section A, 1 from section B. Okay, so if 2 from section A are glowing, just only 2 resistors are drawn. One only from section B, in the sense only one resistor, remaining are turned off. There is no current flow through that. If there is no current flow, then we can replace those resistor. We can remove those resistors. That is the meaning. The question they are asking is ratio of power consumption. Formula for power is E square by R, right? So based on the given voltage and resistor, we can replace it as E square by R. Okay. So these 3 resistors are connected in parallel. So resultant is R by 3. These resistors are connected in parallel. So resultant is also R by 3 because they are equal resistors. So the remaining circuit looks like this. This is E and R by 3 and R by 3. These two are looks like they are connected in series. So resultant resistance is going to be 2R by 3. It's 2R by 3. I need power dissipation. Power is equal to E square by R, and that R is 2R by 3. 3 goes to numerator. So final answer is 3 E square by 2R. So this is case 1. Okay, so that's why I'm writing it as P1. This is the power dissipation in section case 1. So let's talk about power dissipation in case 2. So these two are connected in parallel. So resultant is going to be R by 2. The circuit you can replace it as R by 2. And this resistance is in series with R by 2, that is R. So which are connected to a DC source E. Again, these two resistors are connected in series. Resultant resistance is going to be 3R by 2. Voltage E. Then power dissipation in case 2, P2 is equal to E square by R. R is 3R by 2, 2 goes to numerator. So finally it is 2 E square divided by 3R. Question they are asking ratio. So ratio of power in case 1 and case 2. So power in case 1 is 3 E square by 2R. Power in case 2 is 3R divided by 2 E square. E square by R by E square will get cancelled. Then we are going to get the answer. It is as 9 by 4. Which option matches? Option C is the correct answer. This is the way of approaching the question. Hope you understand. Let's move on to the next question. A filament bulb of 500 watt and 100 volts is to be used in a 230 volts main supply. When a resistance capital R is connected in series, it works perfectly and the bulb consumes 500 watt. Then the value of resistance. Okay, super. Let me draw the diagram first. Question number 39. A bulb and a resistor. Which are connected in series to a supply voltage. What's the supply voltage they have been? 230 volts. This is the supply voltage. What's the rating of the bulb they have given? 500 watt, 100 volts. So whenever you come across numericals based on the bulb, first of all, try to find out resistance of the bulb from the given data. Okay. 100 volt and resistance, this is capital R. The question they're asking is what's the value of R? Okay, super. So how much voltage is bulb is drawing? How much voltage is dropping across bulb? 100 volts, right? Let's say this is 100 volts. 100 volts is dropping across the bulb. What's the remaining voltage? Remaining voltage will be 130 volts. This is the voltage which will drop across the resistor, because in a series So whatever the voltage that you are giving, source voltage, that will drop across the all the elements here. So plus minus, because current always flows from positive to negative, right? Wherever it is entering, current is entering, that is positive, remaining is a negative. The question is, I have to find out what's the value of resistance. So if you observe this, let me find out resistance of this bulb. So how to find out resistance of the bulb? We can find out with the help of given rating of the bulb. Formula for power is V square by R, right? Then R of bulb is equal to V square by P. What is the value of V? It's 100. 100 into 100 divided by 500. It will get cancelled out. Then R, bulb resistance, is equal to 20 ohms. So we know voltage across that bulb is 100 volt and resistance is 20 ohm. We can find out the value of current flowing through that. So let me replace this circuit so that it will be very easy for us to understand also. This is how we can replace. This is 230 volt. So and resistance is 20 ohm for that bulb. This is capital R. Voltage across this bulb is 100 volt. Voltage across this resistance is 130 volt. So plus minus, this is how current is entering. So I know voltage across this bulb and its resistance. We can find out current by using I is equal to V by R. Value of V is 100, R is 20. So 5 amperes of current will flow through this resistor. Same current will flow through this unknown resistance also, right? So current flowing through the circuit is 5 ampere. Now just observe this resistance, unknown resistance. We know the value of voltage across that unknown resistor, that is equal to 130, and current flowing through it also. So let's find out the value of resistance. R is equal to V by I. Value of V is 130 volt divided by current flowing through it is 5. Then answer is going to be 26 ohms. Which option matches? Option C is the correct answer. That's the way you have to approach the question. Got it? Let's solve the next question. Two metal wires of identical dimensions are connected in series. So meaning of identical dimension is their length and area of cross section is the same. Okay, so if sigma 1 and sigma 2 are the conductivities of the metal wires respectively, the effective conductivity of the combination is okay. So question is very clear. They said identical dimensions. Meaning of identical dimensions is the length and area of cross section is same. So just observe this. Two wires are connected in series. There are identical dimensions in the sense their length, area of cross sections. Let's assume this is L1 and this is also L1. So first of all, let me write down it is as L2. This is A1 and this is A2. As they said, identical dimensions. L1 is equal to L2 is equal to L. A1 is equal to A2 is equal to A. But their conductivities are different. This is sigma 1 and this is sigma 2. So what is the formula for R equivalent? As these two are connected in series, R equivalent is equal to R1 plus R2, right? R equivalent formula, it's actually resistance formula in terms of length and area of cross section is rho L by A. In terms of conductivity, it can be replaced as L by sigma into A. Let me write it down. So L equivalent divided by sigma equivalent into A equivalent is equal to R1 is L1 by sigma 1 into A1 plus L2 by sigma 2 into A2. So L equivalent can be replaced as 2L. 2L1 or 2L2 or 2L, both are same. So observe here, L equivalent in the sense total length of this conductor. Total length of this conductor is L1 plus L2, right? As L1 and L2 both are equal, we can replace it as L itself. As L1 and L2 both are same, so we can cancel them. L will get cancelled. What about A equivalent? Area of cross section doesn't change, so it will get cancelled out. So what I am left with, 2 by sigma equivalent is equal to 1 by sigma 1 plus 1 by sigma 2 can be replaced as sigma 1 plus sigma 2 divided by sigma 1 into sigma 2. So finally sigma equivalent is equal to 2 times of sigma 1 sigma 2 divided by sigma 1 plus sigma 2. This is the way. Okay, which option matches? Option C is the correct answer for question number 40. Okay, so let's move on to the next question. Question number 41. So question number 41 is a circuit contains an ammeter, a battery of 30 volts and a resistance 40.8 ohms. All are connected in series. Okay, so let's draw that circuit. So one is a resistance and then ammeter. All of them are connected in series. Okay. So what's the value of the resistance they have given? That is 40.8 ohm. Applied voltage is 30 volt. They are given additional information. If the ammeter has a coil resistance 480 ohm and a shunt of 20 ohm, the reading of ammeter. Okay, so this ammeter, for this ammeter they have given some data. So this circuit again can be replaced as this resistance is 40.8 ohm and the ammeter resistance, so it is its internal resistance is 480 ohm and shunt 20 ohm. So this is how it is connected. Now this is connected to a supply voltage of 30 volt. Okay, so this is how circuit is given. Now we have to find out what is the current flowing through the ammeter. So this is completely ammeter. Current flowing through the ammeter, in the sense we have to find out current series current. That's all. Current flowing through this series circuit. First of all, let me find out equivalent resistance of this parallel combination of resistors which are of internal resistance of the ammeter. 480 and 20 are connected in parallels. Then R equivalent of that ammeter alone, it is going to be 480 into 20 by 480 plus 20, which is equal to 500, right? 480 into 20 divided by 480 plus 20 is 500. So zeros will get cancelled. Now 48 into 2 divided, which is approximately 19 point, not approximately, exact value 19.2 ohms. This 19.2 ohms is connected in series with the 40.8 ohms. So the circuit is going to look like this. 40.8 ohm and this is 19.2 ohm. 30 volts supply voltage. Current flowing through the circuit is I. This current is flowing through this ammeter also. That's what we have to find out. Now these two resistors are connected in series. 40.8 plus 19.2 is equal to 60. Then current I is equal to V by R. V value is 30 volts. R is 60, which is equal to 1 by 2, which is equal to 0.5 amperes. So this is the current flowing through the ammeter. That's the answer. Okay. Next, question number 42. A, B and C are voltmeters of resistors R, 1.5 R and 3 R respectively, as shown in the figure. When some potential difference is applied between X and Y, the voltmeter readings are VA, VB and VC respectively. Then, so they are asking relation between VA, VB and VC, and they gave internal resistance also. Let's try that. This is the circuit that they have given. Okay, so let me replace this circuit in terms of the resistors. Just observe this circuit. Observe the second circuit. I just replaced all the voltmeters in terms of their resistors. So we know one thing, that whenever there is a parallel circuit, so voltage across parallel is always the same, right? So that is the thing we can directly answer. That means VB is equal to VC because they are connected in parallel. We can assure that. But the thing is, we have to compare with A also. Let's compare first. Before comparing, just let me find out equivalent resistance of voltmeter B and voltmeter C. Then we'll cross check whether it is going to be same or different value. So internal resistance of equivalent resistance of bulb B and C are, these are two resistors, 1.5 R and 3 R are connected in parallel. Then R equivalent of this combination is 1.5 into 3 divided by 1.5 plus 3. So 1.5 into 3 is 4.5, and this is 1.5 plus 3 is also again 4.5. This will get cancelled. So numerator we have R square and denominator we have R. R also will get cancelled. Then R equivalent is equal to R itself. That means, so this is how the remaining circuit looks like. Equivalent resistance of bulb B and C is also equal to R. A is also equal to R. Voltage across A is VA. Voltage across B and C both are same because they are connected in parallel. So if I give a supply voltage V across these two combination of resistors, as their internal resistance is same, definitely I am going to get equal voltage. So let's say voltage across this is V by 2 and voltage across this combination is V by 2, because they're of equal resistance, right? Total voltage is V given. So voltage across A and B and C combination is also same. So total voltage is equal to VA is equal to VB is equal to VC. Observe this point carefully. So I'll repeat again. So combination of B and C resistors is R, nothing but voltmeter A and B and C combination both are same. So voltage across A and B and C combination both are same. That means VA is equal to VB is equal to VC. Which option? Option C is the correct answer. Okay. Let's solve next question number 43. Two rods are joined end to end as shown. Both have a cross-sectional area 0.01 centimeter square and of 1 meter long. One rod is of copper with a resistivity of 1.7 into 10 power minus 6 ohm centimeter. The other is of iron with a resistivity 10 power minus 5 ohm centimeter. How much voltage is required to produce 1 ampere in this rod? Okay, how much voltage is required to produce 1 ampere? That's what they're asking. First of all, we have to find out what is the resistance of those two combination. These two are, looks like they are connected in series, right? Let's observe this. Both are of same length or a different length? Same length and of same cross sectional area. So length is of 1 meter long. This is also of 1 meter. Area of cross section they have given 0.01 centimeter square. Let's convert into meter square. That is 0.01 into 10 power minus 4 meter square, which can be replaced as 10 power minus 6 meter square. So resistivity of copper and iron is given. So resistivity of copper is equal to 1.6 into 10 power minus 6 ohm centimeter. Let's convert into ohm meter. So into 10 power minus 2 ohm meter, because I just converted centimeter into meter. Similarly, resistivity of iron is 10 power minus 5 ohm centimeter. So let's convert into meter, 10 power minus 2 ohm meter. So this can be replaced as 1.7 into 10 power minus 8 ohm meter. So this is 10 power minus 7 into ohm meter. First of all, we have to find out resistance of copper. Resistance of copper formula, rho copper divided by L by A. And resistance of iron is rho of iron L by A. So this rho copper is 1.7 into 10 power minus 8, length 1 meter divided by area of cross section 10 power minus 6. And what about this? resistivity 10 power minus 7 into length 1 meter divided by 10 power, what do you call, area of cross section 10 power minus 6. Okay, so if this goes to numerator, it will become 10 power plus 6, so it's going to be 1.7 into 10 power minus 2. So this one, if this goes to numerator, it is going to be 10 power plus minus 1. Okay, so resistance total R equivalent is equal to R copper plus R iron, which is equal to, so 1.7 into 10 power minus 2 can be replaced as, let it be 1.7 into 10 power minus 2, and this one we can convert it as 10 into 10 power minus 2. Okay, so that is resistance of iron. Just have to add both of them. It's going to be 11.7 into 10 power minus 2 ohms. So they have given current is as 1 ampere, and in voltage across them, voltage V is equal to I into R. I value is 1 ampere into resistance is 11.7 into 10 power minus 2, which is equal to 0.117 volts. Which option? Option D is the correct answer. That's the way to answer. Got it? Okay, so let's move on to the next question. So observe question number 44. A 12 centimeter wire is given a shape of a right angled triangle ABC having sides 3 centimeter, 4 centimeter and 5 centimeter as shown in the figure. Okay, so resistance between two ends AB, BC, CA of respective sides are measured one by one by a multimeter. So they're asking the ratio of the resistances. Okay, that means whenever you are finding resistance between A and B, so these are the terminals. So these two resistors looks like as if they are connected in series. So first of all, let me write down what are the values of resistors 1, 2 and 3. Let's write this. Let's say this is R1, R2. Between B and C it is R2 and this is R3. Okay, so R1 is so the complete wire is of same material, right? So resistivity of complete material is going to be same. So it's going to be rho L. L value is 3 divided by A. Area of cross section is the same. What about R2? R2 is equal to rho L by A. R3 is equal to rho L value is 5 centimeter divided by A. Okay, so this is the value of resistance of the wires AB, BC and CA respectively. Now the thing they are asking is resistance between AB, BC and CA. Let me replace this in terms of resistors. The circuit looks like this. So let's say this is A, B, C. This is R1, R2. This is R2, R3. Now first case they are asking resistance between A and B, right? So this is the resistance they are asking. If I am finding resistance between A and B terminals, so these two resistors looks like they are connected in series. So remaining combination is connected in parallel with R1. So let's observe that. So resistance RAB looks like this. RAB is equal to R2, R3 looks like they are connected in series. R2, R3, R2 plus R3. So this R2 plus R3 combination is connected in parallel with R1. So into R1 divided by R1 plus R2 plus R3. This is the resultant resistance of those three combination. So R2 value is 4 rho by A, R3 5 rho by A into R1 3 rho by A divided by 3 rho by A plus 4 row by A plus 5 row by A. Okay, so from this, as denominator is same, so numerator can be replaced as 4 row plus 5 row, 9 row by A. 9 into 3, it's going to be 27 row square divided by A square divided by 3 row plus 4 row is 7 row, 7 row plus 5 row, it is 12 row by A. So 1 row by A will get cancelled. Answer is 27 divided by 12 row by A. So this is the resistance between A and B terminals. Okay, so this is how we have to find out resistance between B and C. Next, C and A also. Let's find out them. So when it comes to B and C, this is how circuit looks like. Observe carefully. Now in this case, I need resistance between B and C. Okay, so this is the terminals B and C. Now these two resistors looks like they are connected in series combination and then in parallel with R2. So these two are in series, then in parallel with R2. So equivalent resistance looks like this. Let me find it. So this is RBC. RBC is R1 and R3 are connected in series. They are connected in parallel with R2 divided by R1 plus R2 plus R3. R1 plus R3 is going to be R1, R3 are 4 row by A and 3 row by A. 4 row by A plus 3 row by A. Let me substitute directly. Both are similar values only, no? So you just can add them directly. That is 7 row by A into R2 is, sorry, R2 and R3, right? This one. R1 is 3 row by A, R3 is 5 row by A. It's going to be 8 row by A, 8 row by A, and R2 is 4 row by A divided by, so if we add all these things, we are going to get 12 row by A, right? 12 row by A. 1 row by A will get cancelled. Answer is going to be 32 row by 12A. This is RBC. Okay, so similarly, let's find out resistance between C and A terminals also. The circuit looks like this. Hope you guys following. This is how we can replace the circuit. I need the resistance between C and A. So these are the terminals. Then R1 and R2 looks like as if they are connected in series. Remaining combination is in parallel with R3. Okay, let's find out R equivalent. So resistance between C and A is equal to R1 plus R2 into R3 divided by R1 plus R2 plus R3. R1 R2 is 7 row by A into 5 row by A divided by 12 row by A. Row by A will get cancelled. 7 5s are 35 row divided by 12A. They're asking ratio, right? RAB is to RBC is to RCA, which is equal to RAB is 27 row by 12A is to RBC 32 row by 12A is to 35 row by 12A. This will get cancelled. Row also will get cancelled. So final answer is, oh, that's the final answer. Which option matches? Option B is the correct answer. Got it? That's the way. Let's solve question number 45. In question number 45, So they are given a ring is made of a wire having a resistance 12 ohm. Find the points A and B as shown in the figure at which a current carrying conductor should be connected so that resistance R of the sub circuit between the points is 8 by 3. Okay, so this question is question number 45. So this is the circuit. A conducting wire is connected at points A and B. So length of this wire is L1 and this is L2. So for the total length of the wire, resistance is 12 ohm. That is L1 plus L2. For this much length, what is the resistance? 12 ohm. Then for L1 length, what's going to be resistance? Let me treat this as R1. It's a trick. In previous videos I have given this trick how to find out if I have a proportionality. That's R1 is equal to, so this value L1 divided by this value, that is L1 plus L2, L1 plus L2 into 12 ohm. Similarly, this is resistance of R1. Similarly, so if total length L1, L2 is resistance is 12 ohm, then for L2 length, what's going to be resistance? That is R2. Then R2, use the same procedure, L2 divided by L1 plus L2 into 12 ohm. So this is R2 resistance. Question they are asking. So they said already between A and B points, resistance is equal to 8 by 3 ohms. L1 length wire and L2 length wire, they look like as if they are connected in parallel with respect to 2 points A and B. That means R equivalent can be replaced as R1 into R2 by R1 plus R2, which is equal to 8 by 3. What's the value of R1? R1 is L1 by L1 plus L2 into 12. R2 is L2 by L1 plus L2 into 12. So divided by R1 plus R2. R1 is L1 by L1 plus L2 into 12 plus L2 by L1 plus L2 into 12, which is equal to 8 by 3. Let's solve this. So in denominator, so if you common 12, it's going to be L1 plus L2 by L1 plus L2 again. L1 plus L2, L1 plus L2, numerator and denominator will get cancelled out. In denominator, you are going to left with only 12. So let's talk about only numerators that I'm going to replace like this. Observe. So L1 into L2 into 12 square divided by L1 plus L2 whole square. So whole divided by again 12 common L1 plus L2 by L1 plus L2, which is equal to 8 by 3. This L1 plus L2 by 2 will get cancelled out. 112 also will get cancelled out. Now I'm left with L1 L2 by L1 plus L2 whole square, which is equal to 8 by 3 into 12. Okay, so just have to cross multiply whatever the possibilities we have, just replace it. Then we are going to get ratio approximately for question number 45. The ratio approximately for L1 by L2, I am going to get it is as 1 by 2. This is the ratio we are going to get approximately. What we have to do is just expand this and cross multiply. So if you find out ratio L1 by L2, you are going to get approximately it is 1 by 2. So which option? Option D is the correct answer. Okay, let's solve numericals based on these circuits. Question number 46. The power dissipated in the circuit shown in the figure is 30 watts Then the question is to find the value of unknown resistance, that is capital R. So just observe these two resistors. These two resistors looks like as if they are connected in parallel, right? Then voltage across these two resistors is going to be same or different. It's the same value, that is equal to 10 volts across this R resistor and across 5 ohm resistor. Voltage is going to be same, 10 volts only. The thing they are asking is total power dissipation is given, it is as 30 watts, right? So we know voltage and internal resistance. So total power dissipated is equal to power dissipated by 5 ohm resistance plus power dissipated by R. So total power they have given, which is 30 watts. Power dissipated by 5 ohm resistance is V square by R, that is 100 divided by 5. Power dissipated by R is again 100 divided by V square by R, that is 100 divided by R. So 520, and this is 100 by R is equal to, send this 20 left side, it is going to be 10. So 1 0 will get cancelled, and R is equal to 10 ohm. Which option matches? Option C is the correct answer. Got it? There are some other different ways also finding equivalent resistance, R equivalent, and then voltage in the circuit is 10 volts. By finding, by using power formula again, V square by R equivalent, which you can equate it to given power. That is another process. This is the easiest way to answer. Let's move on to the next question. If power dissipated in 9 ohm resistor in the circuit shown is 36 watts, potential difference across 2 ohm resistance. Okay, so this question is based on the cells combination. With the help of that cell combination, whether it is series aiding or series opposing, by using that method we can answer this question. Let me draw the circuit. So this is the circuit that they have given, and one hint they have given is power dissipated in 9 ohm resistance is 36 watts. So let's talk about this. Okay, so power formula, either V square by R or I square R, you can use both of them. Let's use V square by R formula so that we can answer voltage across 6 ohm also, because they are connected in parallel, right? Power is equal to V square divided by R. So the value of power is 36 watts and V square divided by 9. Then V square is equal to 36 into 9. Then V is equal to 18, because root 36 is 6 and root 9 is 3. 6 3 is 18. So this is the voltage which appears across the 9 ohm resistor. Okay, let me draw that. So voltage across this is 18 volt. Then what about voltage across 6 ohm resistor also? Same or different? Same, because they are connected in parallel, right? So voltage across both 9 ohm resistor and 6 ohm resistor is going to be same, because they are connected in parallel. So this is how it is represented. So what is the symbolic, sign of that voltage? As this is the source, let's say this is plus and minus. Current always flows from positive to negative like this. So let's say this is I. Total voltage dropped across these two resistors is 18 volts. What's the total voltage in the circuit they have given? Oh, okay, they didn't give. Okay, no problem. Okay, so this is how current is flowing. I know the voltage across these two resistors. First of all, find out current flowing through this. What is the current flowing through this? 18 by 9, 2 ampere. And what about this? 3 ampere. 18 by 6, 3 ampere. So these two currents are entering at the junction, then leaving current is going to be 5 ampere. That is the value of total current in the circuit. So I is equal to 5 ampere. This is how it is entering. This is plus minus. So 5 amperes is flowing through the resistor 2 ohm. I know current flowing through it and resistance. then voltage across 2 ohm resistor is going to be I into R, that is 5 into 2, which is equal to 10 volts. Which option? Option C is the correct answer. Got it? That's the way to answer. Let's move on to the next question, number 48. A wire of resistance 12 ohm per meter is bent in the form of a circle of radius 10 centimeter. The resistance between its two diametrically opposite points is A and B as shown in the figure is. Okay. So a straight wire is bent in the form of a circle. So total resistance of that wire is 12 ohms per meter. Okay. To form a complete circle of radius 10 centimeters. So they given radius of this, which is 10 centimeter. 10 centimeter can be replaced as 0.1 meter, right? So what's the total length? So total length is going to be 2 pi r. So that is the total length of the circle. Okay, which is 2 pi into r is 0.1 meter, which is equal to 0.2 into pi meter. So our total, what is the resistance per unit length? They have given 12 ohms per meter, right? If for 1 meter resistance is 12 ohm, then for 0.2 into pi meter, what's going to be resistance? Then R is equal to proportional to 0.2 pi divided by 1 into 12, which is equal to 0.6 pi. Okay, sorry. Okay, so total resistance of this wire R is equal to 0.2 pi into 12. So that's what I given earlier also. You are going to get 2.4 pi ohms. But we are dividing it into two parts. This is the first half or second half. Then resistance of each part, let's say this is L1 and this is L2, sorry, and resistance R1, R2. So R1 is equal to R1 and R2 are of same length. So resistance is going to be 1.2 pi ohm and R2 is also equal to 1.2 pi ohm. As these two are connected in parallel, then R equivalent is going to be 0.6 pi ohm. So based on R equivalent is equal to R by 2 formula. Which option is correct for this question? Option D is the correct answer. Okay, let's move on to the next. Let's try next question. In this circuit shown, the current through 4 ohm resistor is 1 ampere. Okay, current flowing through 4 ohm resistor is 1 ampere. Okay, next. When the points P and M are connected to DC supply or DC voltage source, the potential difference between points M and N they are asking. Okay, first of all, let's find out voltage across this. V is equal to I into R. I is 1 ampere, voltage or resistor is 4 ohm, so it's going to be 4 volt. This is plus and this is minus. As these two resistors 4 ohm and 3 ohm are connected in parallel, then voltage across this 3 ohm resistor is also 4 volt because they are connected in parallel. So this point is connected to directly to point P and this negative is connected to directly to point M. So voltage across this point P and M is also same, that is 4 volt, and the sign is plus and minus like this. Hope you understand. Just observe over there. Okay, now it looks like a voltage division rule. So equivalent resistance of these two is going to be 0.25, and just observe this one. So this part alone I am going to replace like this. So this is the voltage, that is 4 volt, and the resistors are replaced like this. This is of 0.25 ohm and this is 1 ohm. This is point M and this is N. I need voltage across M and N terminals, nothing but voltage across 1 ohm. So we know the formula, voltage across 1 ohm is equal to total voltage in the circuit, that is 4 volt, into same resistance, that is 1, divided by sum of these two resistors, that's going to be 1.25. so it can be replaced as 400 divided by 125, 25 5s and 25 16s. So which is approximately voltage across 1 ohm resistance is equal to 3.2 volt. That's the answer. Which option? Option B. So understand the trick that I just used over there. I just used voltage division principle. So question number 50 answer. Observe the question. A current of 3 ampere flows through 2 ohm resistor. Similar model. 3 ampere is flowing through 2 ohm resistor shown in the circuit. The power dissipated in the 5 ohm resistor. Okay, so let's find out voltage across this 2 ohm. So current flowing through it is 3 ampere. Then voltage across this is going to be 6 volt. Okay, now what is the voltage across this 4 ohm? Also voltage across this 4 ohm is also 6 volts, just because they are connected in parallel, and this is plus and minus. Now this 6 volts voltage is present across this 1 ohm and 5 ohm, right? Let's use voltage division method and then find out voltage across this 5 ohm. Voltage across 5 ohm is 6 volt into same resistor 5 divided by 5 plus 1 6, which is equal to 5 volt. 5 volt is dropping across the resistor 5 ohm. Question they are asking power dissipated in the 5 ohm resistor, that is P is equal to V square by R. V square is 25 divided by 5. So P is equal to, answer is 5 watt. Which option? Option B is the correct answer. So if you don't know voltage division and the current division, in a previous video I just explained that how can we find out voltage division and the current division. Just go through that video, so we'll get an idea. Okay, so thank you. So I'll continue in the next video. Have a nice day.